So we'll solve, I'll solve today's Leetcode, daily Leetcode problem. Cool. So what do we have here? You, okay, along the square streak in an array, you are given an integer array nums. A subsequence of nums is called a square streak if the length of the subsequence is at least 2. And after sorting the subsequence, each element except the first element is a square of the previous number. Return the length of the longest square streak in nums, or return -1 if there is no square streak. Okay, what? I did not understand anything. You were given an integer nums, subsequence of nums, subsequence is called square streak. If the length of the subsequence is at least 2, after sorting the subsequence, each element except the first element is a square. Ah, okay. Return the length of this longest square streak in nums, so return -1 if there is no square streak. A subsequence is an array that can be derived from another array without deleting some or no elements without changing the order of the remaining elements. I see. Okay. What nums.length is 10 by 5. Uh, okay. And numsify is less than or equal to 10 by 5. Right. Mm, okay. So we are supposed to return the length of the longest square streak. Okay. Okay. Mm, interesting. Okay, so mm, so one observation that I'm making is um okay, one observation that I'm making is so we have 4, 3, 6, 16, 8, 2 in our first example. So if we do decide to choose 2, we'll see if 2 square 4 is present in the array, and it is present 4. And we'll also see if 4 square 16 is present, and that is also present. And after that, we'll try to see if 16 square, which is 256, is present, and that is not present. So if we do start by looking at 2, we look at 4 and we look at 16. So once we look at these elements, we don't have to process these elements again, right? So basically what I'm saying is we don't have to look at each element. We can maybe start with the smallest element and maybe have like a while loop and see if the square of that element is present or not. And if it is present, uh, maybe we can we can put all these elements into a set so that, it makes searching simpler. Mm, and yeah, that's pretty much it, I think. Uh, yeah. Mm, yeah, so if we do this right, I think we should get a solution with O of n time complexity. But but the trick is we should always look at the smallest element that we currently have and also remove elements. So, hmm, can we use a set here? Can we use a set here? If we use a set, the problem is we will not be able to access the smallest element. Mm, but if we use a list, we can't get O of n time complexity. So, what do we do here? Mm, so, okay, so let's say I sort the input array. So it is going to become 2, 4, 6, 8. Now it is going to become 2, 3, 4, 6, 8, 16. Is that correct? Yeah. So, and let's say I have sorted this, and maybe let's have like some other array called processed, and that will basically hold, uh, or we can, instead of having a processed array, we can have a processed set, and initially it'll be nothing. So I'll traverse the array from uh, left to right, and uh, or instead of processed, I think I'm gonna call it not processed, and I'll have everything 2, 4, 6, 8, 16, and 2, 2, 3, 4, 6, 8, 16. And when I am going from left to right, uh, mm, while maybe like a while loop that checks if this element is not processed. And while it is not processed, we can process all of its squares, right? And then, yeah, I think that should work. And that should be of n time complexity. So I'll start coding that. Uh, I'll be able to explain it better if I code it, I think. So yeah, not processed is equal to, or what is a better name? Mm, left, remaining. Yeah, I think remaining is equal to set of nums and nums dot sort for num and nums. If num not and remaining, it means we've already seen num before. And on a side note, we should also think about the result. So I'll have result is equal to, okay, the length of the subsequence is at least 2. Makes sense. So, uh, so it has to be at least 2. So I'm gonna have result equal to 1. Yeah. And in the end, if result is equal to 1, it means we have to return -1. So if num not and remaining continue, because if it is not and remaining, it means it has been processed. So we can just continue. Uh, cur is equal to num while cur in remaining. Um, I'm gonna do Result plus equal to 1. Uh, you know what? Uh, I'll have best and LD is equal to norm, and cur is going to be the cur length that we've seen so far. So I'm going to do cur plus equal to 1, and I'm going to do best is equal to max of best, comma, cur, and well, cur in remaining. Yep, this has to change to while LE in remaining. And LE is going to be LE square. And also what we have to do is we have to remove element from remaining because we processed it. Uh, yeah, that should work, I think. And it should be O of n. It should be O of n, yeah, because we're iterating through the loop once. And we are going through the elements in remaining, but then once we go through an element, we're removing it from remaining. So it should be O of n or O of n. Uh, and we just return best. Return best if best not equal to -1, else. Sorry. Return best if best not equal to 1, else we return -1. That should be pretty much it. And the overall time complexity is going to be n log n because we're sorting nums here. So yeah, should work. Nice, it does work. 2, 3, 5, 6, 7. Yeah, that is gonna work. Okay, I'm gonna add a sample test case. I don't know. 9, 81, 2, 4, 64, 16. No source consists of values from what? Number source consists of values from 2 to 100,000 only. Did we have something greater than 100,000? Oh, okay. 1. Okay. Are they unique elements? They haven't mentioned that the elements are to be unique, so yeah, okay, it does work. So let's submit. Nice, yeah, that's pretty good. Solution, binary search. To optimize, we can use binary search to find the square of a given number. Okay, so further optimization is possible. That doesn't need to be considered again as, yeah, okay, makes sense. So what is the complexity? N into log n. Overall time complexity is n log n. Once the number has been part of the tree, it doesn't need to be considered again. All this we can use a set to track numbers already being processed as part of C, excluding them from being reconsidered. Hmm. We can now just set, yeah, you know what, this is better. This is what I've done. So same. What time complexity is of n? Oh, what? Initialize variable longest equal to 0, create a set unique numbers, iterate through each number and input array adding into unique numbers. Iterate through each number in the start and the current. Okay. Initialize current streak to 0, current as a long integer, enter a loop that continues while current exists and unique numbers increment current streak. Okay. Python 3. The start number in nums. Hey, is nums sorted? It is not, right? Uh, iterate through each number in the input array. Fine. Continue the streak as long as we can find the next square in this set. Okay. Break if the next square will be larger than 10 per 5. Okay. And update the longest streak. Okay. Wait, how does this work? If the algorithm iterates, it potentially checks the sequence of squares after the time complexity for processing each and resolve log. And considering all elements, the overall time complexity becomes log and resolve and log 10 to the power 5. What? How does this even work? I have no idea. Okay, let's see map. I think map. Uh, hmm. Yeah, see, it's kind of deceiving to call it second solution. Yeah, that makes sense. It is n log n, right? Show on reply. I actually have no idea what the second solution is doing and why it's working. Okay, maybe for another video, I'll go through the solution. I'll see if I understand it. If not, uh, I'll ask one of my friends to explain it for me, I guess. Yeah, that's it for this video. Thanks for watching, and see you next time.